Today we are going to review simplifying algebraic expressions, which basically means that you have to combine your like terms. It's going to make it all simpler, which is why we use the word simplifying. So we're going to work through these problems together, then you'll do the practice work that is given to you afterwards to show independence in the topic. So what I like to do when I'm combining like terms, I go step by step. I like to highlight or underline the terms that are the same. They have to look exactly the same. So for number one, it's really easy. I have a 3a, a 2a, and a minus 5a. They all are actually the same. They all have an a afterwards, which is great, and that means that we can combine them all. Now we go left to right, and I like to change my subtraction into keep, change. So if I were to rewrite this, I have a 3a plus a 2a. Then when I do minus 5a, it changes to keep, change. So whenever you see minus a number like minus 5a, it's the same as a negative 5a. So we're going to go ahead and do this from left to right. So when we have 3a plus 2a, we have 5a. Then plus a negative 5a, that's just the same as 5a minus 5a, which is 0. You don't even have to put an a in there at all. The answer is 0. And that's the first example. Now, those terms had all of the same like terms, which is really easy. But on the next one, it's not so easy. We have two different terms. We have our terms that have x's in them, and then we have terms that are regular constant numbers. That's what that's called. Okay, so we have the constants. So I like to underline, as you saw, with different colors, or what you guys can do is you can underline them because you guys are using pencil. So I put one line under the first term, and these terms are the same, so I like to put 2 lines under them. All right, so when we are changing from our subtraction, what this really means is we have 3x plus a negative x, which is also the same as negative 1x. All right, then we have a plus 3, and then instead of minus 2, it's plus a negative 2. So again, these are our like terms, and then these are our like terms. So when we have 3x plus a negative x, that's the same as a negative 1x. So it's also the same as 3 minus 1, which is 2x. Then 3 plus a negative 2 is the same as 3 minus 2, which is a positive 1. And that is your answer. You will not have one term as your answer because we have two different like terms. We have like terms with variables and then our constants, which are our regular numbers. And that is your answer. And the next example, it's the same thing. We underline our like terms. I have x's here, and then I also have our y's. Now, if you have a y by himself, that means that there is a 1 in front of it. Okay, so that's 1y. If you have the x by himself, it's a negative 1x. So now we have to combine our like terms. So we have 3x minus 1x, or plus a negative, if you guys want to keep change. And that becomes a 2x. Then you are left with 1y plus a 4y. When you do that, you get a positive 5y. Because it's positive, I added a plus sign, and that's your answer. You cannot combine the 2x and the 5y to make 7 because they do not have the same variable after them. This fourth example is a little harder because you have to make sure that your like terms are the same. I'm seeing that in some of them, x is squared, and in others, y is squared. So we have to make sure that we combine the correct like terms. So when x is squared, we have these two problems, or these two terms. Now let's talk about these. When y is squared and there's an x, they are like terms, even though we have this situation where the x comes first and then the x comes second. That's okay. They're still like terms. They have the same variables, and that's okay if they're out of order. So I'm going to go ahead and do x squared y minus x squared y. Now, when there's no number in front, always keep in mind it's 1. So this is basically 1x squared y minus 1x squared y. 1 minus 1 is 0. These guys actually end up canceling out. Then we go ahead to the next one. We have xy squared plus 2y squared x. Remember, even though the order is off, we still have like terms because they both have a y squared and they both have an x. Now, there is a 1 in front of our first term because there's not a number written. So we have 1 plus 2. Well, that is 3. And then we can put them in whatever order. I like to make it alphabetically in order so the x comes before y. But make sure you square that y squared. That is your answer because our first two terms canceled out. And that's our complete answer. On this last example, we don't have 2 like terms. We have 3. So we have 5p and minus 4p. We have minus 3q and 4q. And then we have 2 and 5. So I underline them all differently to show that they are different from each other. So what we have to do now is combine our like terms. We have 5p minus 4p, which is 1p. We have negative 3q plus 4q. Well, that's 1q because negative 3 plus 4 is 1. And then we have 2 plus 5, which is 7. Now, we have simplified all of this, but we have to now bring it together. To bring it together, you just combine everything. If they're positive, you are adding them. So it's 1p plus 1q plus 7, and that is your final answer for this example. These are the exact problems you will work on your practice worksheet, so make sure that you come back to these notes. If you need to listen to the video again, that is fine, but please try and underline or highlight the terms that are the same. It will help you so much. If you see a minus term, like in our example 2, we had a minus 2. That also means negative 2. Those mean the same things. And keep that in mind when you're answering your questions.